Hey there. In this video, we are going to talk about just what it is we mean in mathematics when we talk about an equation as being an identity. Now, the term identity in math refers to a mathematical statement, or in other words, an equation that is valid for all possible values of a given variable. And as we'll see in a little bit, the key here is possible, meaning all values other than any that are not permissible because of either a given or implied restriction on that variable. Now, I've got a few simple examples that we can look at here. They summarize some pretty straightforward basic facts, but they're all identities because, as you'll see, they work for all possible values of the variable. So if you look at this first one here, all it says is that 1 times some number, n, is always going to be equal to n, that number. If you think about it, that makes sense, right? You've probably likely known for a long time now that, say, for example, 1 times 17 is equal to 17, or 1 times 3.8 is equal to 3.8, or 1 times negative 6 is equal to negative 6. You could put any number, substitute any number in there, and you'd find that it's a true statement. Very similar, the second one here, 0 times some number is always going to be equal to 0. So, for example, 0 times 123 is always going to be equal to 0. 0 times 2/5, if we want to write it as a fraction, is always equal to 0. Or 0 times negative 10 is equal to 0. All right, this third one, again, similar idea here. Some number n divided by that same number is always going to be equal to 1. So you could substitute a whole variety of numbers in there and find that it would be true. 120 over 120. 120 divided by 120 is 1. 1.23 divided by 1.23 is equal to 1. And so on. Again, you could pick a whole variety of numbers in there. But before we move to that last one, there is actually a restriction in this case here, what I mentioned up above. And that restriction is that there's one value that is not permissible in this expression on this side. And that value, as you may have guessed, is 0. So the restriction on this is n cannot equal 0. And that's simply because the expression 0 divided by 0, the 0 on the bottom there in the division, dividing by 0, is undefined. That expression is undefined, so that is the one value that's not permissible in that situation. But other than that, you could choose any other value and it would be valid. So it is an identity. This last one here, that one might not look so familiar, and I'm not sure why I used x in that one and n in all the other ones, but x still just represents a number, any number. Let's just use a simple number here for this one. This says square root of x squared is always equal to absolute value of x. So let's just use 3. So 3 squared, and then take the square root of that. So that would be square root of 9. 3 squared is 9, and square root of 9 is 3 on that left side. On the other side, we have absolute value of 3. Absolute value of 3 is 3, so those two sides are equal. Now you might be thinking, are there any restrictions on this? You might think 0 or negative numbers. We could put a 0 in here and you'd find that it's going to work. 0 squared is 0, so square root of 0 is 0, and absolute value of 0 is 0. Works for 0. Even a negative number in here, if we put a negative number in there, I'll get rid of all those zeros. Let's just try negative 5. Negative 5 on that side. Negative 5 squared is positive 25. You square a negative number, you get a positive. So square root of 25 is 5. So we get a positive 5 there. And on the other side, absolute value of negative 5 is positive 5. Now that's just 3 different examples of numbers that work there, but you'd find any number you substitute in there, it works. Now, thinking about these are pretty simple examples, but more or less you can write a whole variety of things and they're actually identities, things that you've likely written down on paper before. More or less any algebraic statement you've written, say for example, multiplying something like 3x times x plus 5, and you wrote that that's equivalent to 3x squared plus 15x this statement's actually an identity when you think about it, because it's true for all values of the variable. You can try something, like let's say we're going to put in here x equals 2. If you substitute 2 in there, if you're going to put 2 everywhere there's an x, you have 3 times 2 times 2 plus 5 on that side, which we can start multiplying it out. 6 times, and then there we have a 7, and then we have 6 times 7 is 42 on that side. If we put a 2 in the other side here, we have 3 times 2 squared. We have plus 15 times 2. So 2 squared is 4, so we have 3 times 4, and we have, let's multiply that out to 30. This is 12 plus 30, which is 42. So we have those two things are equal there on both sides. So that's just verifying it with one number, but you could pick any one of an infinite number of numbers, and you'd see that that would work. Now, just to make it, maybe one last thing to make it clear here, we've used the word talking about equations, right? These are all equations that we've written, these identities, and these are special equations where they're true for all values of the variable. Probably when you first learned the word equation, you learned it with learning to solve equations, and you'll say something very simple like this. Now, I'm not trying to insult your intelligence or anything, but just want to point out, you refer to that as an equation, but likely what you were asked to do with that is solve that equation. Now, you can probably look at that and just recognize that the solution to that is x equals 3. Now, when you solve it and say that x equals 3, that's because that's the only value that's valid in this equation up here. It's not valid for any other value. If you were to put in some other number like 9 here, 9 plus 7 is 16. 16 is definitely not equal to 10. You can choose any other number, it doesn't work. It's only valid for one value of the variable. It's not valid for all values of the variable, right? So that statement right there is not an identity. All right, it's an equation, but it's not an identity. And that's one simple non-example, but any other equation you've solved in the past would be a non-example, like 3x squared plus 10 equals 74 minus x squared, right? You can have the variable in more than one place, but obviously isolating that, 4x squared is 64 over here, x squared is 16, x is -4 or 4, right? Two different solutions, but it's still, those are the only two that original thing is valid for. If you put any other number in there, 3 times 10 squared, for example, 300. 310 is what this whole side would be. And on the other side, if x is 10, 10 squared is 100, and 74 minus 100 is -26. -26 is definitely not the same as the other side here, which was 310. So there's just one value that it doesn't work for, and since it doesn't work for all values, it's not an identity. All right, that's it. That's what an identity is and what it isn't. An identity is a mathematical statement that is true for all possible valid values of the variable.